In this video, we're going to discuss the domain of radical expressions. We can take an even root of a positive number, but not a negative. The square root of 4 we know is going to be 2, because 2 times itself is 4. But the square root of negative 4 does not equal 2, because it is impossible to get negative 4 by multiplying 2 by itself. Even negative 2 doesn't work, as negative 2 times itself negative 2 is positive 4. With this in mind, though, we can find the domain of the square root of x minus 3 by simply remembering that under the radical sign must be a number equal to 0 or greater. So we set up this inequality. We take x minus 3 is greater than or equal to 0. Solving for x, we realize therefore the domain of the square root of x minus 3 is x is greater than 3. Written in interval notation, of course, that would be the square bracket for 3, because it's greater than or equal to positive infinity. Looking at this problem, square root of x plus 4 plus 3, we only have to worry about the radical sign, so we could ignore the 3. So we set up this inequality. X plus 4 is greater than or equal to 0. Solving for x, we realize therefore the domain of the square root of x plus 4 is that x has to be greater than or equal to negative 4. So when written in interval notation, that's negative 4 to infinity. Looking at this problem, though, we now have the cube root of x minus 2. We know we can take the cube root of negative numbers. So there is no restriction on odd number roots, whether it's cube root, sixth root, ninth root. So all real numbers are going to work for x when we're dealing with odd number roots. So interval notation for all real numbers, of course, is negative infinity, comma, positive infinity. And don't forget, we need to use the curved parentheses because we can never actually equal infinity.